Welcome to part 3, where we'll be covering how to do specular lighting in our shaders. Now, once again, don't worry if you find this presentation a little hard to follow. It's just to get an idea of how things work. After the theory, we will go ahead and write a shader line by line, explaining how it works in greater depth. You can then come back and watch the theory again for greater understanding, or you can download the presentation, a source shader, and a text version of this tutorial in the source files. Let's begin. Specular shading. Specular shading takes our existing Lambertian shader and adds in a specular highlight. This specular highlight is a point of light that follows halfway between the view direction and light direction. Take a look at the code. Although there's only one line of code, it's a pretty long line. We have this line here. Let's go ahead and break this down so that it's a little more understandable. Alright, so what we have here is we have a reflection vector. So we create our reflection by reflecting the light across the normal. Unity has a function for this called reflect. Now you notice we're going reflect negative light direction by normal direction. Now the reason we use negative light direction is because by default the light is pointing at the object, the normal is pointing away from the object. So we reverse that so they're both pointing away from the object, and that way we can get our reflection. Alright, what we do then is we then take that reflected and we do a dot product between the reflected vector and our view direction. This here will get our reflection point on the surface. So it'll get that 0 to 1. So to make this make sense, when as our reflected vector gets closer to our view direction, it will become 1. When it gets further away, it becomes 0. So that's how we get that point that is halfway between our regular, our light direction and our view direction. What we do next is we use the max function to make sure we don't have negative values on the other side of the object, just like we did with the Lambertian model. Now, by using the power function, we can raise the specular highlight to a power to get control over the intensity. So what we're doing here was we're taking our new dot product, which has been taken in by that max function, and we're taking it to the power of a predefined value, shininess. That shininess is just a little slider, and it lets us control how intense that little highlight is, whether it's a very soft specular highlight or a very sharp specular highlight. Now, if you're unfamiliar with what the power function is, what it is taking to the power of something. So 2 to the power of 4 is the same as going 2 times 2 times 2 times 2. So it's just exponentially making it more intense. Next, what we do is we multiply it by the same dot product from our Lambertian shader. So in this way we can fade the highlight away as it approaches the edge of the lit area. Otherwise, what will happen is we get a specular highlight on the wrong side of the model, away from the lighting, and that just doesn't make sense. Now we could just use a max function. Instead of doing that, by doing the dot product, it will just make it a little softer. It'll soften it out on the edge, rather than having just a harsh cutoff. Alright, finally, we multiply our specular highlight by our attenuation, and our specular light color, just like we did with our fuse model. Alright, so that was pretty quick. Now that we've covered the theory, it's time to put it into practice. I'm now going to create a material and shader in Unity 4, assign the material to a surface, and create a vertex slit specular shader from scratch. I will be explaining a lot of this theory lesson again as I write the shader, so don't worry if this was a bit too fast or if this doesn't make any sense at all.